Okay, so in that last video we worked through how to find the inverses. You're given a function, we had this whole swap x and y formula. So in the second video, and this is going to be pretty quick, we're going to learn how to determine if we give you two functions, like say I give you an f of x and a g of x, we're going to be able to determine yes, they are inverses of each other or no, they're not. So here's how it works, and it's pretty simple. It cuts back to what we did a couple sections ago with composition of functions. So it says two functions f and g are inverses if and only if this is true. If we compose f with g of x, meaning if we plug g of x into f of x, and if we plug f of x into g of x, they both come out to equal x. So I've got like a three-piece equality here because they're saying they're both equal to the same thing, they're equal to x. So if I plug g into f, I should end up getting x. If I plug f into g, I should end up getting x. You should test both of them just to confirm that they both come out to be x. Okay, so I've got just one example to look at. Like I said, we're just trying to figure out if these are in fact inverses of each other. So we're going to do f of g of x and g of f of x. So let's start with f of g of x. Okay, so remember, f of g of x means we are going to go into our function f, and every time we see an x, we're going to replace it with g of x. Okay, so I'm going to do some color coding here for you. So 3/4, instead of the x, I'm going to sub in g of x. I guess I should probably put that in parentheses. And then minus 6. All right, so it was exactly the same as this function used to be right here, except I replaced the x with a g of x. Okay, that's all this means. If there was a 3 here, you'd replace the x with a 3. So we've got equals 3/4, and then what I'm going to do is I'm going to sub in the actual function for g of x, which is right up above. So sub that in, and then I have minus 6. So now do whatever we need to do to clean up. We'll simplify it up as much as we can. If it turns out to be x, we're in a good place. So we've got 3/4 times 4/3 x. Notice these 4's will cancel, the 3's will cancel. All I have left is the x, which is a good thing. 3/4 times 8. If I picture this as like 8 over 1, I have 3 times 8, which is 24 over 4. And 24 over 4 reduces down to 6. And then I have minus 6. And look at that. Just what I was hoping for here, I get x. So that's a good start. But remember, just because this one gives me x doesn't mean the other one will. So I've got to test the other one as well. If this doesn't give you x, then you can stop, because they both have to be x. So if one of them turns out not to be x, you may as well just stop there. Okay, so now I'm going to go into my function g, which is this one right here, and replace the x with an f of x. So I have 4/3, and then in place of the x, I'm going to plug in f of x plus 8. Okay, so I'm right in this function here. Instead of the x, what I did is I replaced the x with my function f of x. So let's see how that turns out. So I've got 4/3. And then in parentheses, I'm going to sub in my expression for f of x. Okay, and plus 8 on the end. So just like I did up above, I'm going to clean this up, see what I get. 4/3 times 3/4, just like it did up above, will cancel out. All I have left is the x. And once again, I can think of that as 6 over 1. So I have 4 times negative 6, which is negative 24, over 3, which is negative 8. Plus 8, and these will cancel out, and I end up just with x. So my answer would be yes, they are inverses of each other. And when it says explain your reasoning, we could say yes, and that's because f of g of x came out to be x, and g of f of x came out to be x. When they both come out to be x, that means they are in fact inverses of each other.